It's a pleasure meeting you all in another video. 2010 question number 18. 2014 question number 50. These both questions carry the same idea. You have a wheel which obeys no slip only roll condition. You are to find the instantaneous speed of a point on the circumference. That should have been one of the few easy questions you all would have approached so far. Ever thought that a single term has the potential to change the entire question and lead you directing the wrong answer? Yet, this term could go unnoticed. To notice the unnoticed, watch the video till the end. Let's understand the concept behind this question. Here are two key terms. First, no slip, only roll. Second, velocity of a point with respect to Earth. These two are the key points of this question. Here we go into the explanation. I have got a wheel of radius r. It rolls on a rough horizontal surface. Let's say it covered a distance of d. What do you think about the arc length that would have come in contact with this flow? If there was no slip but only roll, then I'll say the arc length that came into contact with the flow is equal to d. S is equal to d. That's the importance of key point number 1, roll without slip condition. Do you know any equation for arc length? Angle covered during this motion is theta, then S is equal r theta. That's equal to d. Dividing either sides by the time taken t, we obtain the equation that r omega is equal to v. So what's the big deal? We know this equation already. V is equal to r omega. But that's not this. Under rotational motion, V equal r omega gives you the tangential velocity V. Here, it's not the tangential velocity, it is the linear velocity. This is an entirely new relationship. With the previous idea of rotational motion, r omega is V tangential equal VL. This relationship would help us a lot. The instantaneous velocity at the topmost point, I'll mark it as A, you will say that's 2V. And at the point which come into contact with the ground, let's say point B, you would probably say the velocity is 0. Ever thought how do we obtain these values if the linear velocity is V? Here we go. We obtain an equation tangential velocity equal linear velocity. For a moment, let's forget this 2V. If the linear speed is V, then the tangential speed is also V. At this point, here also the tangential velocity is V, but the direction is to the left. You must get the idea. When we say tangent or tangential velocity, that is the velocity of that certain point with respect to the wheel. So velocity of A respect to wheel is V to the right. Velocity of wheel respect to earth is again V to the right. In our question, we are supposed to find velocity of A respect to earth. By the velocity principle, velocity of A respect to earth is velocity of A respect to wheel plus velocity of wheel respect to earth. That's V to the right plus V to the right, we get 2V to the right. The velocity of A respect to earth is 2V, but the velocity at A respect to wheel, or otherwise the tangential velocity, is v. How about the velocity at b? Velocity of b respect to v is equal v to the left. Velocity of wheel respect to earth is v. Velocity of b respect to earth is 0. That's how you obtain the velocity at a as 2v, velocity at b as 0. You can find velocity with respect to earth at other points too. So far, we have been having questions based on velocity of a point respect to earth. Which term has got the potential to change the entire term? That's this. When you say velocity of a respect to earth, we will have a variation, a speed versus time variation similar to this. If a starts from ground, the variation would be something that varies from 0 to 2v. What if in our upcoming papers we have question based on a respect to wheel? Is that 2v 0 root 2v on points a, b and c? That's not that. The velocity of a respect to wheel is the tangential velocity, and that's equal to the linear velocity. The speed at any of this point. Here we are wanted to draw the speed versus time graph. So let's see what's the speed. The tangential speed about any point on the circle. Let's say A rotates as far as the linear speed is same. The tangential speed is also v. It remains constant. It remains at v. So far, we are having question based on velocity of a respect to earth, velocity of a point respect to earth. In our upcoming papers, if we got velocity of a respect to w, this should have been the graph. There is an interesting part about this. Let's think we have a wheel of radius r has a linear velocity of v. Another wheel of radius 2r has a linear velocity of v. What do you think about their tangential velocities? Will it be twice as this? Is that so? It's not. Irrespective of the radius of the wheel, as far as no slip only roll condition is satisfied, the tangential speed is equal to the linear speed. Then the velocity is still v. Here also the velocity, tangential velocity is v. You could prove this yourself. Just go through the explanation what I did before and see if this satisfies. If you all have got any doubt regarding this,